All right. So last time, and I'll just bring up so you can see it real fast. Last time, what we did is when we wanted to solve a system of equations, like this one here, we just graphed each of the lines and tried to figure out where the point was that it intersected. And then we did that problem where we had the age, right? The age of Bill and Jill. And when we tried to do that graph, it was very difficult to determine what that point was, because our graph is only as good as how good we draw it. So today we try and find a new way to do this where we won't have to rely on the accuracy of our graphs to get a solution. So what we're going to be looking at is what's called substitution. So solving linear systems of linear equations using substitution. So that's the method. Okay, so let's start. I'm going to just do an example, okay? And then after we do the example, I'm going to kind of give you steps. And then, by the second or third example, hopefully you'll get the pattern of how this works. But there is a process. There are a set of steps. So like on a cheat sheet on the test, I allow you to have a little cheat sheet. You might want to write the steps down on there once we get to a formal set of steps. But let's just start with this example. Example, we have a system. Remember, if you have a system, you put that little brace there. And let's do 2x plus 3y equals -2. And then the other one, y equals x plus 1. Now, if this were last class, right, we would try and do this by graphing. And I don't know, how would you graph the second one? Because it seems to be easier. Would you do the intercepts, or would you do the y equals mx plus b? Remember, there were two different ways to graph lines? Yeah, the y equals mx plus b, because you already have it, right? Y equals mx plus b. So that one would be easier to do. You know the y-intercept is 1. You know the slope is 1. But on the one on top, if you try and do the intercepts method, you're going to wind up getting fractions. And if you try and solve for y, you're going to get fractions. So it would be a little bit troublesome if you do it that way. But it could still be done. Now here's how substitution is going to work. What I'm going to do is I'm going to look at both equations, all right? So I'm going to focus my attention on both of these. And I'm going to ask myself, let's call the first one, we'll call it L1. Or if you want, we'd call it equation 1. L2 or equation 2. L meaning line, right? And what you want to do is look at the two equations and figure out which one does it look like is easier for you to solve for one of the variables, to isolate one of the variables by itself on one side of the equation. So which one looks easier? This is kind of the second equation, right? The second equation, it would be very easy to get the second equation solved for one of the variables. Why? Because it's already solved for one of the variables, right? So we notice that the second equation, we already have it solved for y. And that's what the goal of substitution is. The first step is to look at both equations, figure out which one is easier for you to solve for one of the variables. Okay, with me? Again, I'll write all this down later. So I noticed that the second equation, right, equation 2, tells me that y is equal to x plus 1. Now, because I have to satisfy both equations at the same time, whatever the y value is in the second equation must also be equal to the y value in the first equation. Remember, we're saying we're trying to find a point that satisfies both at the same time. So whatever y is in this equation has to match up with what's up here. So what we're going to do is the critical step of this process, which is make a substitution. We're going to substitute this y into the first equation. So now is the critical step called substitution. We substitute y equals x plus 1 into equation 1. Now, what do I mean by that? Well, let's write down the first equation. This is the first equation, right? I'm going to replace my y in that equation with what? X plus 1. Because what we just got from the second equation up above is that y must be x plus 1. So everywhere I see a y in the first equation, I replace it with an x plus 1. Follow? Okay, so let me rewrite this. It's 2x plus 3. Now, what goes here? Parentheses. X plus 1. Close parentheses. Why is it so important to have a parentheses there? The original problem said 3 times y, right? Whatever y is. If y turns out to be 2 things, the 3 has to distribute to each one. So I put the x plus 1 there. So there's my replacement of y. And then what's the rest of the equation? Equals -2. Now, look at this right here. Let's see if y'all can start talking to me in a little bit of math language. What is that? Mathematically speaking, forget the rest of the problem. Look at that line. What is this? It's an equation. I agree it's an equation because it has an equal sign. Good. What else? It's linear because you have x to the first power, right? And it's one variable. That's the key. It's a linear equation in one variable. Not 2 variables anymore, right? Up here in these problems that we had to begin with, we had equations, right? They were 2 variables, though. We've now reduced it all down to a linear equation in one variable. And we learned in the very beginning of class, first day, we were solving linear equations with one variable. And so what we had to do is go through this process of isolating the variable, and we had a whole set of steps. But for us now, because we've passed that test and we're like halfway almost through the semester, we just look at this and say, okay, we need to solve for x. So let me first remove parentheses by distributing the 3 through the parentheses, right? So I'm solving for x. So I'm going to put that step here. I'm going to solve now for x. So distribute the 3 through, and you get 3x plus 3, right? Equals -2. Now what? After you remove parentheses, you can combine like terms. 5x plus 3 equals -2. Okay, now what? Move the 3 over because you're isolating the variable term right now. So subtract 3 on both sides. We get 5x equals what? -5. And then finally, to get x, divide both sides by 5. So you get an answer here. I'll bring it right up here. X is -1. Well, remember, the whole goal is to find an x and a y, right? We have apparently, according to what the procedure is, it looks like we have found the x, haven't we? The only thing we have not found yet is the y. However, if you go back up now, and remember we had this written down here? This equation right here? We said y was equal to x plus 1, didn't we? So what we're going to do now is we are going to substitute. That's why they call it substitution. We substitute twice in here. We substitute that answer into that equation. and that will give us y. So now substitute x equals -1 into equation 2. So remember, equation 2 said y was equal to x plus 1. Replace now your x with -1. What's -1 plus 1? 0. So it appears that the answer is -1 for x and 0 for y. So if I just move up here, I'm going to come all the way back up here. I'm going to write my answer up here. My answer needs to be a point, so I need to write it like an ordered pair, the x first, then the y. So I put -1, 0. Notice I have no graphs, right? No graphs. Now, if I were to go graph these, what we're saying is that these two lines will hit each other, right? And they will hit each other at that point, -1, 0, which would be on a graph. Here's -1. It would be right there. I can't tell you what the lines look like, but I can tell you that's where they hit. Now, how could you check your answer? Plug them in, right? Plug them into the original problem. Plug in -1 for x right now into the top one. What happens if I plug -1 right here? Get -2. What happens if I plug in 0 for y? It's gone, right? So I have -2 equals -2. Is that true? Yes. Now, let's try the same thing here. Plug in 0 for y here, and then here plug in -1 for x. -1 plus 1 is 0, so it's true. So we have found the point that satisfies both equations simultaneously without any graphs. Questions? Okay, let's try another one. That one was a little too easy because it was that equation was already solved for y, wasn't it? So it made it a little bit easier, too easy for us. So let's try this example. X plus y equals 3, -2x plus 3y equals 9. And then just right here to the side, I'm going to put equation 1, equation 2. Just so I have a reference. When I talk about it, you'll know which ones I'm talking about. All right. First step is to try and identify which of those equations would be easier for you to solve for one of the variables. So which one looks easier to get, like either the x or the y by itself? The first equation? Think so? Right? Okay, so I'm going to choose equation 1, comma, now I'm going to solve in that equation for what? So what would it be easier to solve for in equation 1? X or y? About the same, right? I mean, it would be the same easiness, I guess you could say. So it doesn't matter which one you solve for, so you get to pick. Now, I'm going to do x here because we did y last time. I want to show you it works either way. So I'm going to solve this for x. Okay? That's what I'm going to choose to do. Take equation 1 and solve it for x. So now I'm going to write down equation 1. And I'm going to solve for x. To solve for x means I need to subtract y on both sides. Right? And what I get is x equals what? 3 minus y, or you could say -y plus 3. Either way. I'm going to just say 3 minus y. And I'm going to box this because I'm going to come back to that later. That's the first step. Pick an equation, solve it for one of the variables. Now what? Substitute that one in to the other equation, right, that you didn't use. And we're going to substitute that in and replace our x with that, 3 minus y. So I'm going to substitute x equals 3 minus y into which equation in this problem? The second one, right? I'm going to plug that into the second equation. So let me go ahead and write out the second equation, which was what was it? Negative 2x plus 3y equals 9? Is that what it was? I don't remember at all writing that. Okay, so there's my second equation, right? And now I'm going to replace my x in the problem right here with 3 minus y. Right? That's what's going to get substituted. So rewrite the problem. I have negative 2 and then parentheses. 3 minus y, then plus 3y equals 9. Now, what are we looking at here? What is this? Linear equation, one variable. You can solve it for y, can't you? So that's what we're going to do. We're going to solve for y. So let's distribute through. We get negative 6. Then what? Positive 2y plus 3y equals 9. Collect like terms. Negative 6 plus 5y equals 9. Now, right, 6 on the other side, so I add it to both sides. So add 6 on both sides. You should have 5y equals 9 plus 6 is 15. And finally, divide through by 5. And you get y is what? 3. All right. I know what y is, don't I? Now what am I going to do with that y? I'm going to take that y and I'm going to substitute it where? Right there where I had solved for x earlier, right? Okay. So that's my next step. I'm going to come up here on the side. I'm going to substitute y equals 3 into the equation x equals 3 minus y, right? Are we going to get 0 again? That's kind of boring. It just turns out it's 0. You're not going to always get one of them is 0. Just the two examples I've done, they're both 0. But we're still going to look and check. X equals 3 minus 3, which equals 0. So what's my answer? Make sure you put it in the correct order. It's x then y, right? So 0, 3, correct? How could you, yes? Okay, great question. We substituted this y equals 3 back into the one that I had boxed here. The question being asked is, can you take the y equals 3 and just plug it in right here, correct? The answer is yes. It turns out that whatever you get here, you could actually take that value and plug it into either one of these equations. Any equation that we have on the page that has x and y in it, we can plug it into. I just always go to this one because it's already solved for x. So there's not a whole lot of work we have to do. Now, we could check this, right? 0, 3. I'll do it quickly. Plug in 0 for x and 3 for y. Is that true? Okay, plug in 0 for x and 3 for y here. Is that true? Yep, 0, and then 3 times 3 is 9. 9 equals 9, so it works. All right. I think I would like you to try one. Do you feel like trying one yet? See if you can do it. I'll work through it at some point, but 3x plus 5y equals 17, and then 2x minus y equals negative 6. What I'd like to do is help you just get started, okay? You tell me what's the first thing you're supposed to do here. Pick an equation, and then pick which variable you want to solve for, right? Which one of these looks the best to you? The equation 2, we'll call it. Which variable? So imagine if I get x by itself. If I get x by itself, aren't you going to have to divide by 2? Know what I'm saying? If I try and take this second equation right here, 2x minus y equals negative 6. If I try and get the x by itself, I move the y to the other side, right? Then don't you have to divide by 2? And you're going to create fractions, aren't you? You could do that, and that it wouldn't be wrong, but is it the easiest choice? What might be better? Second equation for y. Because, see, y has a negative 1 in front of it. And so you'll never have to divide by a number that would create fractions elsewhere in the equation. Do y'all understand what I'm saying there? It's important that you try and pick your battles wisely here and go with the easiest thing possible. So my recommendation, choose equation 2, solve it for y, then do your substitution. I'll pause the video. I'll walk around and answer questions. Okay, so like we had said before, I'm trying to pick a variable that looks like it's the easiest to get by itself, which would be this y. So I'm going to choose equation 2, and I'm going to solve for y. Let me label these. I noticed that on some of your work going around, some of you are getting the answers, that's great. Some of you are struggling with it a little bit. What I didn't see really much from anyone is kind of listing out what you're doing. So that could be dangerous if you go back to review for a test or read your notes or do homework and you're looking at your own work going, what did I do again? So if there's something that you think you need to put it, add to your work there, I suggest adding it, all right? Unless you think you're going to remember all the steps, no problem, all right? So I'm choosing equation 2, I'm solving for y. Here's equation 2. I'm going to try and solve for y. What I saw a lot of people do is move the 2x to the other side. I have a different kind of idea here. Because y is negative here, if I add y to both sides, I get, what they cancel on the left, I get 2x equals negative 6 plus y, right? And now let me add 6 to both sides. That'll get rid of the 6's on the right. That gives me y equals, and I have 2x plus 6. It's the same thing as a lot of you got, but a lot of you had to either multiply by -1 or divide by -1 to get that. I'm just pointing out that it can be done this way also. Move the y over so it becomes positive. Okay, once you know what y is, you box it up, and you take that answer and you substitute it where? Substitute y equals 2x plus 6 into the equation that you did not use to get y, right? You used the second equation to get y. You substitute it back into then the equation 1. If you accidentally substitute y equals 2x plus 6 back into the equation it came from, you're going to get everything to cancel. And at some point, you'll get something like 0 equals 0 or a number equals a number. So it just takes you in a big circle and you're kind of stuck. So make sure you go substitute back into the equation you didn't use. So I'm going to write the equation I didn't use. 3x plus 5y equals 17. I'm going to replace what with what here? The y with the 2x plus 6, right? And then I still have equals 17. And now I'm going to solve this linear equation in one variable. So I distribute 5 through. 3x plus 10x minus 15 equals 17. I'm just seeing if anyone's paying attention. All right. Should be what? 30. Okay, thank you. Just want to know if I still have you or not here. All right, so 5 times 6 is 30. All right, now collect like terms. 3x and 10x is 13x plus 30 equals 17. I will subtract 30 on both sides to isolate the variable term. So I get 13x equals what, negative 13? And then divide both sides by 13. So x is negative 1. Once I have x is negative 1, I substitute that answer into this one, the one that I boxed before. So substituting that into here, I get 2 times negative 1 plus 6 equals y, which means 4 equals y. Negative 2 plus 6 is 4. Bless you. Now your answer needs to be written in order. So negative 1, 4. That's our final answer right there. Questions? What do y'all think about this method? You like this? Okay. Let's try and write out some steps. And I want you to see in us writing out the steps how it can be a little challenging to write out steps for a process like this. Okay, let's try it. Let's say that we have 2 equations. What are the steps for solving? For solving. Okay. The first thing we're going to do, choose what? Choose one of them, right? Choose an equation and solve for either x or y, right? X or y. Your choice, right? You got a lot of freedom here, don't you? You can choose the equation, you can choose the variable, but try and choose the easiest. And that's where things can get a little bit hairy, because on a test, someone might do it one way, another student might do it another way. Everyone should get the same answer no matter what, but the algebra can be a lot harder if you choose the wrong one. Okay, once I've chosen that, what do? So I've chosen the equation, what do? Solve for the variable you chose, right? So solve now, solve that equation for the variable you chose. Is that right? Chose? C-H-O-S-E? Right? Not choose, right? Chose. Is that right? Doesn't look right. Any English people want to help me here? Is that right? Anyone disagree? Period? Okay, thank you. How about exclamation point? Do you see why these steps are weird? Because we don't know what equation that is. That might be equation 1, it might be equation 2. We don't know if we're solving for x or for y. It all depends on the problem. Do you see why the steps are kind of weird? Okay, so we choose an equation, we solve for either x or y. Solve that equation for the variable chose, right? Now substitute, right? Ooh, substitute your answer from part 2, right, from the second step into what? The other equation. You see how this sucks to write steps for this? It can be confusing, which is why it's so important for you to understand what you're doing. If you rely on the steps, you got to really be able to read your steps to know what you're going to do. So substitute answer from 2 into other equation. Okay? When you do that, right? When you do that, you will have a linear equation in one variable, won't you? So what you'll do is you will solve that linear equation, one variable, from step 3. What do you do after you've solved that? Plug that into what? Which one? The one from step 2. Plug answer from step 4 into step 2. Step 2's equation. I mean, that's basically what the steps are if you try and write them down, and they're confusing. Here's the book's steps. The book has the same, like it has a process. It's their first step, isolate one of the variables from one equation. Isolate one of the variables from one equation, all right. Substitute the expression found in step 1 into the other equation. That's pretty much what we said. Solve the resulting equation. Substitute the value from step 3 back into the equation from step 1. Find the value of the remaining variable. Then they say check your answer. So if you don't like the steps that we wrote, you can follow the books. They give you the same thing. Let's see here. La la la. Oh yeah, you're gonna like this. 2x plus 3y equals 6. Y equals negative 2/3. Oh no, my brain is melting. Right? Fractions, you hate them. All right, but this is a system of linear equations in 2 variables. So we can either try graphing the lines or we can try the substitution method from today. The great thing about substitution method, we will get the exact answer. If there's an answer, we're going to get it. So let's go through the process. Which equation you want to solve for? Second one. Let's solve for y because it's already solved for y, right? So equation 2, I'm going to choose equation 2. I'm going to solve it for y, which is already done for me to start the problem. So there was a bit of give and take here, right? The good news, y was solved for. The bad news, there's a fraction. What do I do with that? You mean like try and clear the fractions? You could, but the important thing is we are going to take that y and plug it right in here. So if you were to clear fractions, you won't have y anymore. You might have something else. And then it wouldn't be a direct substitution. You can replace y with y, but you can't replace y with 5y or something like that. Okay, what do I do with this? Plug it into, okay, so I'm going to plug y equals negative 2/3 x plus 4 into equation 1, which means I'm taking 2x plus 3y equals 6, and I'm replacing the y with that nasty looking thing, negative 2/3 x plus 4 in parentheses, don't forget that, and we still have equals 6. Everyone okay with that? Replacing the y with that thing that we got earlier. Now distribute. What happens when you take 3 and multiply it times negative 2/3? What do you get? Negative 2, and then you have x, right? Negative 2x. What's 3 times 4? 12 equals 6. Uh-oh. What happens? The x's cancel out completely, don't they? And you get what? 12 equals 6. Does 12 equal 6? Not today. Right? What does that mean? Our method sucks and it doesn't work all the time, or what? What does that mean? That means there's no solution. Right? This statement is not true. 12 is not 6. Now, last class we talked about this when we were graphing them. We said there were 3 possibilities when you take 2 lines. What are the 3 possibilities? They can be parallel, which means they don't hit at all, which means we don't have a solution. They can hit at one point, which is pretty much everything we've seen today up until now. And then they can be the same line on top, one on top of the other. If you get something like this that doesn't make sense, that means they're parallel. That means there is no solution. So I'm going to write that down. No solution. We don't have to do any more work. Three dots is there for 0 with a line through it means empty set. You could probably get away with that. That would be, yes, that's usually reserved for an equation with one variable. You say empty set, no single solution, but it's not completely wrong, because empty set means we're saying what are the answers here, right? They're supposed to be points. What are the answers? And you're telling me it's here, it's nothing. It's the set of nothing. So it's not wrong. So I would accept that also. What do you think would happen if we had worked through this and they were the same line on top, one on top of the other? We would have worked through it, and then at this point what we would have gotten right here is we would have got something like 12 equals 12. What if we would have got 12 equals 12 instead of 12 equals 6? Well, does 12 equal 12? Yes. So at that point we would stop and we would say infinite solutions, because they're the same line. Right? I'm not real big on giving you problems like that on the test. I usually give you problems where it's going to be a single point, and that's all that happens. Okay, I want to see how bad the book is to you here. The book, I'm trying to see if the book gives you any fractional answers. Yes. I want to give you one that has fractions, and then we're going to call it a day. Because we're going to wind up coming back after spring break and talking about all this again, probably, because, well, spring break, right? When I was in college, I'll never forget a spring break. I forget what year it was, but it was South Padre, You know, all my guy friends and girlfriends and everyone, big group of us, would go down to South Padre. And one of our groups didn't show up. We all left at the same time. They didn't show up. We were getting worried about them. Wound up, he had a big Bronco truck, whatever, and he had rolled it. There was like 4 or 5 guys in this Bronco, and they had rolled it, but they were okay. But their windshield was all busted out, right? So they show up at South Padre. They keep coming, right? They're not going to miss out in South Padre. So they keep coming, and they drove most of the rest of the way without a windshield, and it was nighttime. So, you know, bugs, nighttime. So what they had done is they had worn their sunglasses, they'd wrapped their heads with towels, and all of them showed up, and they had like bugs, all these bugs all over their like shirts and stuff. It was hilarious because, you know, they get out of the car, and they're all covered with bug guts and everything. It was so funny, but they were there to party, man. It wasn't going to stop them. Wasn't going to stop them. Okay. All right, what about this one here? We do have a system of linear equations in 2 variables, so we are going to follow a process of substitution. We choose an equation, we choose a variable. So how about equation 1? You like equation 1? I like equation 1. What do you want to solve for in equation 1? Y? Okay, I have no problem with that. So I'm going to solve equation 1 for y. So I write x plus y equals 1. I move the x over, it becomes y equals 1 minus x. We good with that? Yeah? Okay. Now I'm going to take that, I'm going to substitute y equals 1 minus x into the first equation. No, sorry, second equation, right? Now we have to be a little careful here because look at what's sitting in front of the y in the second equation. What's sitting there? A minus sign, right? That minus sign is really like a negative 1. So it's going to have to distribute through to both the 1 and the negative x. You all see it? Very important that you see that there. So go ahead and distribute that through, and you should get 2x minus 1 plus, right? Plus x equals negative 2. Questions? What now? Collect like terms. 3x minus 1 equals negative 2. Move the 1 to the other side by adding it to both sides. You get 3x is negative 1. And finally, divide by 3. Do not break out your calculator. You will leave this as a fraction, negative 1/3. So x is the fraction negative 1/3. Now how are you going to get y? Take that back up there and plug it into that other equation, right? So y equals 1 minus, but what was x? Negative 1/3. What do you get when you subtract a negative? Subtraction of a negative is the same as addition, right? Subtract a negative. I'm doing, instead of 1 minus negative 1/3, I'm really doing 1 plus 1/3. And how do you add those two together? Common denominator, right? I change my 1 into a 3/3. And then that's going to, now we can add because they have the same denominator, I get 4/3. So my answer, written as an ordered pair, is negative 1/3, 4/3. I'm not going to work through this problem. I just want to put it up here and point something out, and then I promise we're going. Do you still want that? Are you done? Just take a look at this real quick, because it's going to be like something on your homework. Actually, this is a homework problem. 3x plus 2y equals 4. 2x minus 3y equals -6. What do you notice about this? It's the first time this has happened. Which equation do you want to pick? They both kind of suck? Is that what you said? No? That's what I was going to say. Okay. Well, I think they both kind of suck because you can't solve for y or x in either one, right? Like, if you look at the first equation, you've got a 3 in front of your x, so you're going to have to divide by 3 at some point. If you look at the y, you're going to have to divide by 2. There's no way to avoid fractions in this problem. There's no easier way to go. They're all equally bad, which means that you just have to pick one and go, all right? So on your homework, you'll see this problem. Just be prepared to pick one of them and just go with it and see what happens. All right, here's your homework, which, you know, it is spring break. So, there we go. Let's go page 292. I'll try and be reasonable here. 13, 17, 21, 29, 2 more, 33, and 37. 37 is the one that I just put up on the board. Remember, all the answers to those problems are in the back of the book, or in the back of your pages, yeah. I forgot the sign-in sheet today, but I think everyone's here except, what's her name? Yeah. Okay, we're okay. I forgot today. Everyone have a great spring break. Be safe.